Hey guys, welcome again, and now let's talk about bitwise operators. Bitwise operators are a very important topic in C++, and it's a little difficult but not too much. As you know, C++ is a mid-level programming language, and bitwise operators means doing operations on every single bit of a variable. Let's say you want to do some operations on every single bit of short or integer like that. So for that, bitwise operators can help us a lot. And in this lecture, I covered a lot of cool topics about bitwise operators, like including bitwise logical operator, OR operator, and of course XOR operator, which can help us a lot. And we have a very good example also, in which I will show you how you can store all the information related to font, a text in a single 16-bit short. That will help you a lot, and you'll learn a lot about bitwise operators in this course. So that will help you understand bitwise operators better. If you want to learn more about C++20, you can find my course. Link will be in the description below, and I'll see you there. But still, for now, let's go and learn more about bitwise operators. As we talked about, C++, it's a mid-level programming language. It means that it is very close to the hardware. So we can do bitwise operations and every single bit of a variable of type integer. So bitwise, like bit, you know the meaning of bit, binary digits. Operators are type operators which gives you the ability to do operations on every single bit of an integer type variable. So let's go to the slides and talk about bitwise operators a little more. This will be a big lecture. I hope you understand the concept well. Let's go. And the first thing we want to talk about bitwise operators, or bitwise operators in C++ used to perform operations on individual bits of an integer value. So that could be an integer, that could be short, long, or long, because all of them are integers. So they treat the operands as a sequence of binary digits. While we're doing these bitwise operators, it is not doing its operations as decimal digits. It says the integer value like the sequence of binary digits and operate on each bit independently. So we have different types of bitwise operators. Like you can see, we have AND bitwise operator, which is a single ampersand. If it is double ampersand, that's not bitwise operator, that's logical AND. And we have bitwise OR operator. We have bitwise XOR operator, which is in XOR, but we don't have logical XOR. We will talk about this, is very cool. And we have bitwise NOT, which can be shown like this. And then we have left shift and right shift. So you might be thinking, why do we need these bitwise operators? Why do we want to do operation as every single digit of integer value? So let me give you a very good example. Sometimes you need to store the information of color like ARGB, like alpha, red, green, and blue. Alpha is for storing the transparency information. So for this, and if you think in our computer screen, we have, like, if it is HD screen, then we have a lot of pixels in our screen, and every single pixel needs to have the information of ARGB, or at least RGB. Most screens are RGB, so needs like the combination of red, green, and B colors, so that can produce the right color for us. For that, if we store all these informations in 4 different integers, which could be like 4 bytes, then we will have lot of memory loss. If you want to store this ARGB information in 4 integers instead of 1, you will lose lot of memory. Why? Let me show you an example. If you go very simple, open a calculator and write here in a single HD screen, we have 1920 multiplied by 180. Now you can see we have around 2 million pixels. So if you want to store the information for every single pixel in 4 different integers, that will become we have to multiply it by 4. That will become 8 million instead of 2 million. Now you can see we have lost 6 million bytes extra. still you think it's not important to store information of ARGB or font style information in a single variable of 2 bytes or 4 bytes instead of storing them in 4 variables of 4 bytes. So that's why it's important to have the ability to do some operations on every single binary digit of a variable, and that way we can control our integers and store as much information as possible in a single integer, 2 bytes or 3 bytes. So let's go and talk about how these operators work. So bitwise operators, we have like AND, OR, and XOR. For now we'll talk about these 3 only, so they're cool and we'll use them a lot. Now let's talk about how the bitwise AND works. Bitwise AND means if like both the operands are true, then the result would be true. X is false, Y is false, so none of them are true. That's why the result would be false. X is true, Y is false, so one of them is false. It means the result would be false. X is false, Y is true, one of the operand is still false, the result is false. Because in AND, X and Y should be true so that we can have a true result. But what about OR? If one of them is true, then the result would be true. If X or Y is true, or both of them are true, the result would be true. So now you can see X is false, Y is false, so none of them is true. X or Y, no one is true, so the result is false. X is true, so one of them is true, the result is true. X is false, but Y is true, so the result is true. X is true, Y is true, the result is true again. But what about XOR? It's kind of cool, and I told you I like it a lot. So now you can see it means XOR means if X and Y, if they are same, then the result would be false. X is false, Y is false, the result is false. So it means both of them are equal, the result is false. But now you can see X is true, Y is false, they are not equal, the result is true. Now you can see here again they're not equal because X is false and Y is true, so they're not equal and the result is true. And finally look at this, X is true, Y is true, they're equal and the result is false. That's why XOR is kind of cool, and it can be used a lot for something like switching, when you want to switch between 2 states. Like you say that bold information on your computer, if you say when you click on that B, your text is getting bold, and when it's bold and you click again on that B, your text is getting normal again. So that's why you're switching between 2 information. Let's say this Y stores the information, our information, that is text bold or not, and this X stores the information of bold, so it should be always true. Now let's say first we write a text that's normal text, so Y is false, and when we click on that, the computer says okay, X is always true but Y is false, then the result will come 1, because X is always true and Y is false, they are not equal, then it means the result should be true. Now Y is true, and if we click on Y again, then computer says okay, they are equal, then the result will become false and the false would be stored again in Y. So that's why like kind of switching between 2 states, bold or not bold, italic or not italic. So that's how this XOR works, and XOR is used very widely. I'll give you some examples. So now let's go and see an example how all these things are working together. But before going to Visual Studio Code, I think we have to talk about our example a little bit, because it should not be confusing in Visual Studio Code. Here we have our example. You can see bitwise operators and the example is right there. We have text information in 2 byte int or short. So short is 2 bytes, and 2 bytes mean that it is 16 bits. Every byte is 8 bits and 2 bytes would be 16 bits. So in 16 bits, which is a lot of bits, we can store all the textual information like font information in that. Let's see how we can do this. If we see unsigned short, so it should be unsigned, that we can use all the bytes for our information, that's this single one should not be used for any signed thing. So we'll declare unsigned short and I'll give it a name of font. Now you can see we can store, like in these 8 bits we can store style information. This would be separator. In 1 bit we can store italic, so we can switch between the 2 states, true or false. In 1 bit we can store bold information, so that it can also switch between 2 states. And in these 5 bits we can store font information, like we can store a lot of fonts in this. Now you can see in one single 2-byte short integer we can store all textual information instead of storing them in 1, 2, 3, 4 different variables. So now Bitwise operators can give us the ability to do operations on every single binary digit of this short integer. Now let's see, if you want to switch only between bold, then we can do that like without bringing any change in font size or italic or style, or we can switch between italic or none without changing any of these information. We can do the same for style and font size as well. So how we can do this? To work with the size afterward, you need to extract information from the font variable. So now you can extract information and store those information in other single variables, so that you can switch between them, like you can switch between different states. For extracting information, you can use bitwise operator. Bitwise operator produce 1 bit only when both bits are true. So if you want to, let's say, extract information about bold, then you have to make all other variables 0 except the bold. You will make bold 1, and like bold is the 6th digit, you will make bold 1 and all others are 0. So now if you use this ampersand between these two, like font and bold mask, you will have the result that whether your text is bold or not. So you can do the same for font size, italic and style as well. You need to define a value that contains ones in the bit options that you're interested in. Like I gave you an example of bold, and 0 in all others. Like I told you these, like font size, italic and all others should be 0 except bold. Or if you want font size, all other information should be 0 except all font size should be 1. So now let me give you an example. If I say 1 1 1, like 5 times 1, and all others are 0. Now if I use the AND operator will say the first digit here is 1 and here is 0. So 1 is true, 1 is false, the result would be false. There, this second one is 1 and there it is 0, so here is true, there is false, so it's false. And this one, third one is true here and third one is true there as well, so that would be true. Fourth one is true here and fourth one is true there as well, so that would be true again. Fifth one is false here, false there, false, and like here all of them are 0, so these ones doesn't mean anything. So now you extracted the font size information only. So that's how it works. It's pretty easy and great to have a mask information. So how you could do the mask information? For that, like you can see, come again, unsigned short, and give it a name like size mask. All the operators like in mask, which is 5, give them 1 and the rest is zeros. Now you can do it like this. You can store the information in an article using art keyword and give it a name like size. And now you can see font, this is font, and using this ampersand, which means bitwise and size mask, you extracted the correct information. Let's go now to Visual Studio Code and see this example in Visual Studio Code, then you will have a good idea about it, how it works. So now, as you can see, I'm in Visual Studio Code, and let's talk about Bitwise operators. It's kind of difficult, it seems a little confusing, but you will understand by an example. Let's go and talk about this example. So I told you we have to write unsigned short first, because we need like 16 bits for font information, and short is exactly 2 bytes, which means 16 bits. So then I'll give it a name like font, then I can assign a value to that in binary. Remember, we want to work with binary, so I'll assign a binary value into short. And for binary, if you remember from the numbers lecture, we have to add extra 0B, so that we can at least have an idea about that this is a binary. Now we need 16 bits. So for 16 bits, we can write like 1, 2, 3, 4, 5, 6. We have a little bit of style information, so I'll tell him 1, 1, and then 0 again. Now you can see we have 8 bits for a style, and adding single quote is not a problem in numbers, so you can use anytime single quote that you can understand or at least have an idea about separating things. And I'll add 1 0, that would be for separator. Let's leave that as that is. Now I will add another bit for italic. Let's say our text is italic for now, and then I'll add another quote, so this is italic information. I'll add 0 for bold, so for now our text is not bold normally, and then I'll add another quote, so we say that's bold. And finally, now you can see we have 8 bits right here, 9, 10, 11, so we have 5 other bits that we can use for font information. So I'll add like 0, 1, 1, and 2 other zeros like this. So now you can see we stored our text information in a chart. This text information, including like these 4 bits, are for size, and this one is for bold, this is for italic, this is just a separator, nothing else, and this is style information. So now all text information in a single font. So what if I want to print this information? If I come and write std and say cout, and then I'll write like say font information is, then I'll simply print font and std. Finally we have into line right there. So now if I save everything, if I come and compile, so let me come here and say build. Now we will have a successful build, and there we go. If I run the program, let's say what's gonna happen now. You can see the result is 844, which is I think exactly the binary value we stored right here. So what's going on? We want to print the binary because these information are in binary. For printing binary, you cannot directly print binary. You have to let's duplicate this, and I'll show you how you can store binary information. So I'll just say I'll give this only font, and to the second one I'll tell him font information, which is binary information. So for printing binary, we need to include a header file called, let's say include, that's called byte set. So byte set can help us with printing these numbers in binary. So this is also standard library. I'll add standard library, and then I'll write byte set. So this is a 16-bit base, and then I'll pass our variable, which is font. So now this way we can print what we want. Let's run our program again, and yeah, this time we have font information, which is exactly the same thing, like 00110. That's the same thing we have right there. So now you can see we stored information, but how can we do some operations on this? So to do some operations on this, like we learned bitwise AND, bitwise OR, XOR, and that thing, I'll declare another variable. So let's say this is also short, and this is size mask. So we want to store the information of size, which are these information in this size mask right here. So I'll tell him this is equal to let's copy this information so we can extract information from here. I'll tell him this is equal to, the first thing we have to do, let's convert all these last 5 digits to 1 and the rest to 0, so that way we can extract the information from the font text. And then let's put this in a parenthesis so we can easily understand what's going on there. Then I'll come here and add bitwise and in another parenthesis I will say font. So now this is size mask, and this is font. So we want to extract the information of size only from font and store it in size mask or size information. Now if I come and copy these two lines, then I'll say this would be size mask. So size mask, and let's say size mask information, size mask information, and I'll just print size mask here also and here as well. So this time if I run the program, we have successfully built, and if I come here, now you can see size mask its integer value is 12, but size mask binary information are only 2 and the rest are zeros. So we extracted the correct information from the size mask. What if we want to check whether our text is bold or not? For that we need to add another mask, and that should be unsigned as well, short, and we want that like bold mask. We'll give a bold mask information, and let's add some information to make it easy. I'll just copy this and let's paste it here. So the last 5, 1, 2, 3, 4, 5 should be zeros. This is bold information. I'll make this one only 1, and then logical operator, and then we can use font right there. So this time, very simple and easy, we can extract the information of bold, whether our text is bold or not, from there. Let's say this is bold mask and bold mask information. Let's print bold mask instead of size mask. This way you can understand we can easily manage the information. Now you can see all or 0, it means bold is false. But what if I come here and tell him I want to make it true or 1, and this time bold is true, and in bold mask our information is true. So this is how we can do. Let me just copy these 2 lines and paste it again. This time I'll extract information for not only size mask and bold mask, this would be for italic mask, and this one will be style mask, and the information of style, I should make this one 0, and let's say 1, 2, 3, 4, 5, 6, 7, 8. So this is 8, 1, 2, 3, 4, 5, 6, 7, 8. So styles for 8 information, and for making the other one easier, or italic, 1, 2, 3, 4, 5. So let's say this is italic information. I'll extract italic information as well. Now we can store those information, like we can print them as well. Very simple. This would be italic mask. Let's say this is italic mask, and this would be italic mask information. I'll just print italic mask right there and right there. Let's copy this one more time and paste it again. So this time it would be for style mask. Let's say this is style mask, and this is style mask information or binary, and let's paste it right here and there as well. Now you can see we extracted information using bitwise and from font information. So this is font information. In this we just calculated, or we combined all the information in the same place. This is size mask. We only have size information here, and we only have bold information there. We have like italic information only in this one. I think I just didn't change this italic thing, so I'll change that, and there we go. Lastly, we have style information. So in italic there is something wrong. Bold. So this is again bold. This one is extra. Now you can see this is for font, this is size, this is bold, italic, and style information. So we have all the correct information right now. Let's do some other operations. This time we want to do, like, now you have an idea about Bitwise, and let's do some Bitwise XOR, which I told you is very cool and I'm sure you'll like it. So to do that, I'll just copy this line, so we will have a separator right here. I'll just make a big separator so we don't have any problem or confusion, and let's make one more end line right there so we have some extra space. Now let's say someone comes and apply a new style. So let's say first do it on size. Someone comes in and says, oh, I want to do some new size, so I'll paste this one here. Now let's say size mask 1. This time I'll say the new size, this I'll just give a normal value to that. So that would say that I want a value like 101, like this. So this is a new size information that we want to apply to our text. So how we can do this? So the new size information, let's store it in somewhere like arrow. I will say arrow and I'll give it a name, new font. So the new font information we want to store is the first thing. We want to convert all of the current, like all these two, to 0, so we don't have anything, and then we can apply a new size. So first we have to remove this size information, and then we can add the new information into that. So to remove the first information, let's add one parenthesis, and inside this parenthesis I'll say font XOR size mask. And this way we can remove the current information from the font, the current size information from the font. If you want to prove it, let's copy these 2 lines of code and then I'll paste it right here. So now in new font information, all the size information should be 0. Let's run the program and see the result. Now you can see, but it's not changed. You can see right here it's not changed. So let's see what's wrong here. First thing, I just don't want to print it's like normal value because we don't need it. We only work with binary, so I just want to print the binary. And second, let's say we stored that in new font, but we printed font, so that was a problem. I have to come and print the new font right here, and there we go. This time if I run it, wow, now you can see right here we removed the size information from the font, and in new font information we don't have size information. Now we can add the new size mask or new size information into this. So for adding new font, we should use XOR again, and this time say size mask 1. So this time we will again use XOR and add size mask 1 to the new font. So this time if I print the new font, and we will see new font have the correct size information, like 1 2 3 4 5 digits. You can see these 5 digits are correct, and it has nothing with the rest, like with bold, italic and style information. That's the good thing. We only work with the size for now. We only change the size information, like just changing different size like that. So we're not doing anything with bold and those things. We can change bold information also. So before talking about bold and italic, let me tell you how all these things are working together. So first we declared a font information, and we stored the binary digits in that, like 16 digits we can store in a short because there's 2 bytes. And yeah, we added this extra single quotes, which has nothing to do with, like, if it is there or not, it means nothing. It's just for us to understand the difference between them. And then we used and like bitwise and operator to take only some, to extract information of size mask, bold mask, italic mask from the font. So we want to store do all those information in single masks so that we can do some operations on them. And then we printed all the values, and we saw the values were correct, like we extracted the correct values. So how this extraction works, this AND operator means like if both of them are true, then the result would be true. Let's see how this size information are extracted from the font information. So we used these first we use this size mask. We added all ones to the mask because we only want these first 5 digits, and then we used and from font. We want to extract information from font. So now computer will compare every single digit and give us the result. Like see, this first one with first one, so this is true and this is false, but for and we need both of these to be true, so it means the result is false. This is false here, the second one is false here. Oh sorry, second one is true here, but second one is false there, so again we have false. Third one is true here and third one is true there also, so we have true because and means both should be true. Fourth one same, true, true and true, and fifth one true here but false there and false, and the rest is false. If it is true here, still it's false. This is false, true, the result is false, and false, false, the result is false, false, true, result is false, false, true, result is false, and false, 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 the rest is false. So that's how we can extract the correct information from those 16 bits. Like we are interested in the first 5, we extracted information to that, and then we stored, like we did this ampersand with all of them, and we extracted all information from, like for bold, for italic and for style, and we stored them, we printed them, we had the correct result. Now let's talk about this little bit. You see unsigned short, like someone now comes in and says, hey, I have new size information, like that was old information, now he changed the size, maybe a little bigger or smaller, but this is new information. So for new information, it means this is new font. So old font had these informations. Like it's not a problem, we can store this in old font so that we don't need extra variables, but to make it very clear, that's why I declared a new variable. So this new variable is like in real program, we won't declare a new variable, we will use the same font information. So for font information, first I took the old information like this information, and then I used this XOR, and I used the old size mask. So I have to remove the old size information from the font. For that, why I use this size mask, because you can see our size information is 0 0 1 1 0 0 0 0, like this. Like our size mask, like old size mask has this information, and old font has these information. So this XOR means if the variables are same, then the result would be false. If the variables are different, then the result would be true. So now you can see first one, they're same, the result is 0. Second one, they're same, the result is 0. Third one right there, the result is same. It's 0. It's 1 here, it's 1 there. It means they're same, so the result is 0. Again 1 here, again 1 here, the result is 0. Again 0 here, 0 here, the result is 0. So we made the first 5 digits which we wanted to make 0, we made them 0, and we have done nothing with the rest of them. Like all these are 0, so it means that it is 0 here, it is 1 there, so it should be 1 because they're not same. Like again this is 0 here, and this is 1 right there, again it's 1, like 0 0 0. That's how it works. So the rest would be the same like it's right there, only the first 5 digits we changed them to 0. That's what we wanted. And now we're coming and applying a new size mask. So new size mask is these informations, and we want to apply this size mask and like the result of this. The result of this is the same font with this information, except this, like the last 5 digits are 0. So now if you want to apply this, now like this is 0, this is 1 here, so the result would be 1. This is 0 and this is 0, means they're same, so the result would be 0. And this is 1, this is 0 right here because we made these two zeros, so these two are not ones, they're 0. So this is 1 here, this is 0 here, the result is 1, they're not same. This is 0 here, this is 0 here, they're same, the result is 0. And this is 1 here, this is 0 here, so they're not same, and the result is 1. and the rest would be like all these are zeros, so it means like we will have the same values right there. So that's like 1 1 0 1 1 0 0 0 0 like that. So that's how we made till now. That's how we first removed the old size mask and applied a new size mask into that. So this was about changing size information. Now let's do some switching. Like I told you, we can switch between bold and non-bold, italic or not italic, something like that. So to do so, first let me add another line separator to this one, so that we can have a little space. And in this place I'll come here and declare another variable, unsigned short, and this would be new font, let's say. So this new font, we already have one new font. I'll give it like new font 1, and this new font 1 we can initialize this new font 1 to have all the zeros. So let me copy this. There are a lot of zeros in there. So we have new font, and this new font have nothing. Let's try and copy and print this one. So I'll say new font, and new font have nothing, all of them are zero. So new font 1 I'll print this time. Now if I come and run the program, our new font is completely empty. What if I want our text only to be bold? So I'll come and say new font 1 is equal to, let's say we have already new font 1, and I'll add XR and say bold mask. So this time if I come and print the same result again, this time I'll say new font 1, and this is bold, like this, that we can understand. We added bold into that one. If I run it this time, now you can see our new font is bold. Like first 5 were empty, which is for size, and the 6th one is bold, that is 1. So this time I'll come and tell him our new font should have italic as well. So let's have a little room right there and say new font 1 is equal to new font. So our new font is already here. New font already have the bold mask, so I'll tell him it should be italic as well. So this time let's print it again, and we will exactly have italic as well. So I'll say this new font have italic as well. Let's run it, and a very quick check. We have a problem, and yeah, we know what's the problem. So this is not what we want. New font 1 is the thing we want. Let's run, and this time new font have, it's bold and it is italic as well. So let's say and tell our new font 1 again. This time we want our new font to have some size also. So new font 1, and say, hey new font, you should have size. So which size we want to apply? We have like a size mask 1, and we have size mask itself. So let's say we want to apply this size mask, or let's say this one, the default or the first one we did. So I'll tell him we want to apply this size mask into new font. So this time let me copy this and print it. So this time we'll say our new font have size as well. So let's print it. If I say we don't have any size information, and let's check why we don't have size mask. Well, our new font, I said new font, but we're talking about new font 1. That's a problem. Let's run it this time, and exactly we have size information right here. So finally we will add style as well. Let's say new font 1, and this time equal to new font 1, and let's say we want style mask as well. And there we go, very well. So let's make them combine, so we have a little clean code. This time if I run it, wow, there we go. We don't have style. Let's say again we will have the same problem. This is what should not happen, because this I did a mistake with the name, but it's okay for now. Let's write our new font have style as well. Now you can see the new font have style, the new font have that style. You can see these two numbers belong to style, these two bold italic, and these are font size. What if I want to remove both? Like if I say this time a new font 1 is equal to new font, I'll do the same thing, new font 1 XR and bold mask. So what's gonna happen this time? What are you thinking? If I come and print the same line this time, and I have to remove the bold because this time we don't have bold. Let's check it. Now you can see bold value is false, so we changed the bold value to false this time because it was already bold. If I come and copy this line again and paste it here, this time we will have bold. So this is the kind of switching thing, like once we click, like this time we click the bold, our text got bolded, and this time again we clicked on bold, our text was already bold, so it switched back to normal text. And once you clicked again on bold, this time text was not bold, so it changed to bold again. The same thing works for italic as well. Let's say what if I come and copy the italic line? So this is italic line. I'll just come here and paste the italic line right here, and I'll print it this time. So this time we don't have italic. I'll just remove the italic from the line. If I run it this time, italic should be false because it was already italic. Text was already italic. So these are information for font size, bold, and this is italic, which is this time false, but last time it was true. So that's how you can switch between different states using bitwise operators, XOR operator, and you can extract information using bitwise AND operator and many more. So this is a lot of code we did in this lecture. This was a huge lecture, and this was an important one also because bitwise operators are a little difficult topic, like this is a little boring topic, and it is very important also that you can understand how binary works, how you can work like extract information from a single short or integer. This is what you can use with integers, long and anyone, but I only use it with short because just imagine integer will have this much digits, so who can work with this much digits? Like working with this much digits will get a lot of time of us, so that's why it's not easy, and I try to work with short only. So this is 16 bits, and 16 bits is a little easier. So and we can adjust all the information like size information, bold, italic information, and also we can adjust style information in 1-2 bytes short integer. So that was an important lecture. I hope you learned something from the lecture. If you still have any problem with this, please ask me in the forum section below, or I will put some links into some important resources that you can find more information about bitwise operators, and you can click on them and find more about that. So I hope you learned something from the lecture about bitwise operators, a very good and cool topic. And a little difficult one, I know, but still, if you practice it, it will be very easy for you. And again, if you want to learn more about C++ 20 very good and cool topics I covered in my new course, you can find the link in the description below. Until next time, peace.